Hey, hello, welcome to the workshop. It's me, John Park, and it is time for another episode of John Park's Workshop. Here we are. Thanks so much for stopping by. I'm excited to have you here today. We got some fun stuff to work on, some things to show and talk about. When I say we, I mean me and all of you. So if you are part of the community and you want to chat, if you want to hang out, then the YouTube chat is a place I'm keeping an eye on. Hello, Dave Odessa, Johnny Bergdahl, Beatagraf Avdalhagen, Randall Bone. Thank you for stopping by. And we also have our Discord, if you want to jump into that. If you're maybe over on Facebook, which actually I don't think is running right now. If you're over on Twitch and you wonder, hey, where's all the chat happening? That's it right there. That is our Discord server. You can get there by heading over to adafruit.it. That's Adafruit, but with a period right before the IT. Adafruit.it/Discord. That's our little URL shortener. That will take you to an instant invite to our Discord server, and then you can look for this channel right here, Live Broadcast Chat. That's where the people are hanging out. We've got Paul Cutler in there. Hello, Paul. Yaniscu7, Johnny Bergdahl, also there. C. Grover, hello. Thanks for stopping by. So before I do anything else, what I want to do is, let's say you want to buy some stuff from Adafruit and you'd love to get yourself a discount. Well, I have one for you. I have a 10% off coupon code that you can use all day today until about midnight East Coast time in the US. Arcade. That's going to get you 10% off in the store. If you want to maybe buy some arcade buttons or a joystick, I don't know, it could be anything. There's no restrictions other than it has to be things, not conceptual stuff such as software, gift certificates, or subscriptions, but physical goods, bits. If you want to buy some atoms from Adafruit and have them shipped to you, then you could use that coupon code right there. That'll get you 10% off. It is arcade. Here's some example things that you could buy. If you just head to Adafruit, you'll see we've got some new products listed there, including the UltraLeap 3DI stereo hand tracking camera. I know nothing about that, but sounds fancy. Sounds maybe like a Kinect or a Leap Motion sort of thing. I don't know what that's about, but it's there. It's $275, but guess what? It'll be $275 minus 27.5 if you want to use that coupon code and save a little money. You can pick up some round displays if you want to start noodling around with those. I don't think we have the driver board for those in particular yet, but if you want to see all the new products, you can click right there on View All New Products, or just go to adafruit.com/new, and then you can check out some of the cool new stuff and pick some up at a discount. So that's the coupon code for you today. It is arcade. So take advantage of that. Let's see what else happens. On Tuesdays, 2 days before today, I have this show right here, the product pick of the week. And on the show, I like to bring you a new product, sometimes an old product, but it's going to be a discounted product. And this week, we sold through 100 of them like hotcakes. It was half off, 50% off for that Cutie Pie ESP32S3. Super great board, super hot board. That's it right there. Here's a little excerpt of the show. No, there isn't, because I forgot to add it back in. I just edited it earlier. Hold on one second. We're going to add a little media file. I forgot. Here it is. Let's make it big. And let's make it not loop. And here you are. It is the Cutie Pie ESP32S3. This is the version that has 4 megabytes of flash and 2 megabytes of PS RAM. You can do so much on this. Use CircuitPython, use Arduino. It's got the Wi-Fi built in. This has native USB. I've got my Cutie Pie right there. I have the iSpy BFF there that allows me to plug in an SPI display. Look how quick this thing boots up. I'm going to go ahead and plug that in, and boom, up and running. ESP Wi-Fi analyzer. This thing will check the local SSIDs in its area based on the little tiny antenna it has on there, and give you a display that tells you about the strength of the Wi-Fi signals that you're seeing. That right there, that is the ESP32S3 Cutie Pie with 4 megs of flash and 2 megs of PS RAM. Haha, almost tricked myself with the audio there. Yeah, that was it. That was product pick of the week. Really cool board. So I'm sure we'll have those back in stock. You just want to go and click on the notify me if you were looking to get some. Sorry, the discount will not apply, but you could probably, next time we get those in stock, use a coupon code from this show or 3D Hangouts or Ask an Engineer and get yourself 10% off on some good Cutie Pie action. All right, so next up what I'd like to do is the CircuitPython parsec. Here we go. All right, let me just bring this window up here. Okay. For the CircuitPython parsec today, I wanted to talk about using the Circuit Playground library to make it really, really easy to play tones on the Circuit Playground Bluefruit or the Circuit Playground Express. So you can see here, I've got the Bluefruit version of this board, and I can use in CircuitPython the Circuit Playground library to make stuff super easy and very consistent type of syntax. So in this example right here, what I'm going to do is I'm actually going to hold this up to my little microphone here that's under my shirt so you can hear it. I'm going to reset and you're going to hear it play some little tones. Okay, so those are just 4 tones that play and then the program ends. The way that works, if you look in the code right here, is that I import the Circuit Playground library as CP, and then I use cp.playTone, and then I give it a frequency. In this case, I'm giving it an A, and the duration. In this case, I'm giving it 1 second. And then this is followed by a B, a C, and a D. So that's that first little set of tones that plays. Now, if I want to go ahead and use the buttons, this is where Circuit Playground gets really nice and easy to teach or to learn. In this case, again, I import that library. And then if the cp.button_A is true, which means that button has been pressed, then we're going to play a C. And again, I'll hold this up to my mic so you can hear it. So here we go. I'm going to press the A button, and it plays the C. If I press the B button, it plays a D, and you can pick any pitches that you want there using a frequency chart. And then finally what I'll do is a version that instead of using play tone uses start tone and stop tone. So what those do is give you the ability to just play a tone forever until you say otherwise. So here, I'm going to go ahead and resave this. You can see from Circuit Playground library, I'm importing CP. While true, the main loop, if CP.button A is pressed, then we're going to start the tone, a 660, an E. It's going to play that until I let go. Same sort of thing with button B. It'll play a G until I let go. And there you can see the else is stop tone, and that's what stops the tones from playing. So again, I'll hold this up, and you can hear that's just going to play that forever and ever and ever. And then I'll press the other button until I let go. And so that is how you can use play tone and start and stop tone inside of Circuit Playground in the Circuit Python library. Let me say it again. So that is how you can use start tone, stop tone, and play tone inside of the Circuit Playground library in Circuit Python in order to make some basic music. And that is your Circuit Python parsec.
Circuit Python parsec.
Gosh, I keep trying to trick myself here. I know we've been doing a lot of fancy synthesis stuff, but this is a really nice, easy, basic synthesizer that is a nice way to get your head wrapped around some of the concepts, some of the basics of just pitch, duration. You don't have to worry about the waveform. You don't have to worry about envelopes. You don't have to worry about filters and things like that. It's just going to be a real simple square wave. How long is it going to go for? What's the pitch? And you can write little melodies with it. You can get more advanced. But in Circuit Playground library, it's all about keeping it simple. So, okay, what is happening next? Let me see. I have a couple of new projects that I'm starting up. So I think I shared most of the wrapping up of the, let me make a new window here, of the Synthio. Oh no, I don't want a new window, I want a new tab. Hold on. There we go. So the Synthio Fundamentals guide, right here, CircuitPython Synthio Fundamentals. I had a lot of those examples up and running last week, so I won't go back over those. But I just wanted to show you, here's the final guide. I haven't blogged about this yet, and I'm still preparing some of the example code, massaging it a bit. And in fact, I'm going to probably switch over to a different board that'll make this even easier than using on the Cutie Pie with a BFF, zero soldering. So I'm going to switch it over to a Feather prop maker, which has an I2S amplifier built into it. You can just plug a speaker right in. So in fact, when we started this guide, I don't think that board was out yet. And so just yesterday, Lamore said, hey, wait a second. Now we've got a board that you can just plug in USB and a speaker and nothing else, and we'll be able to do these examples. So I'll be cleaning up that code and committing it for these examples here. These are the simple Synthio examples. I don't believe I had these last week. These correlate to the examples that I did using this right here, which is the VCV rack examples. So I have little example movies of some of the fundamental concepts and the signal flow of how that synth works. And now we have examples that are done right in CircuitPython using Synthio on a board with a speaker and an amp. And these are, I think, going to be helpful for people who want to get up and running pretty quickly. You can grab some of the sample code and then adjust it for your needs. We do some MIDI stuff, some MIDI CC stuff, using LFOs for tremolo and vibrato. And then I have this page of advanced examples here. By the way, I should mention the code snippets are based on Toddbot's not CircuitPython, Synthio tips and tricks page, which is linked in the guide. You'll be able to see that here. And then just adapted for the sort of needs of the particular board or simplifying things even further for these examples. So in the more advanced stage, we get into creating these little single cycle waveform buffers that can be in shapes like a sine wave, a triangle, a sawtooth, the square, and then go way, way beyond that and start using wavetables taken from some other open source synthesizers, and then morphing between them, the ability to switch on the fly the shape of the wave in a nice, easy way. So really cool stuff that you can do, but simple, I think, simple enough snippets to grab and build the synthesizer that you want. So go check that out. That guide is live. And then also I have some links to some of our larger examples that are up in their own Learn guides. I've got the Terrell desktop synthesizer. We've got the Circle of Fifths Euclidean synthesizer that Liz Clark made. Really cool. Go check that one out. As well as this Computer Perfection synthesizer. And then these are some of Todd's larger examples, the monosynth, the wavetable polysynth, and a little mini arpeggiator. So we've got a lot of examples there, and I hope that'll get you up and running quickly with your own synthesizers built in CircuitPython. All right, so next up, what I've got, like I said, I've got a couple of new projects coming down the pipe, and they are going to be video. Actually, I think I've got 3 that are going to be video game controller, video game automation things. And the first one I think I'll be working on is going to be a Pokemon automator. So the challenge here, as well as with some of these other projects, is a lot of the times we've built video game controller projects that use USB to send keyboard commands or mouse commands, but typically keyboard commands. So a lot of game systems and computers in particular, you can build your own controller and then send direct input or USB HID, which is pretty straightforward. However, for some more modern consoles, it gets pretty tricky. The Nintendo Switch, for example, I've got one right here. The Switch uses its own Bluetooth game pads. So these little guys here are Bluetooth. You can get more advanced ones. I think this one's called the Pro controller. So that's also a Bluetooth controller. But the Switch does have USB-C on the bottom. So you'd think, yeah, I can probably plug a controller into that, right? Wrong. It does not use the same standard as other things. I don't know a lot of the details of it, but I don't believe it understands, or maybe it partially understands, but gets confused by direct input or X input, which are both pretty common for computers and Xbox. This uses switch. It's its own thing. So what do you do? What do you do if you want to build in the case of the Pokemon automation project, we're going to have a computer, a laptop, that is looking at HDMI output coming from the Switch, analyzing it, and then telling over serial a microcontroller to then, through the USB port, control the Switch. What we need is a microcontroller that can speak Switch output. So thankfully, if you remember this project from Robert Smith, he built a really great Learn guide. In fact, I've got it here somewhere. Yeah, here he's got this great Learn guide on using the Fisher-Price controller as a video game controller for a bunch of different systems, including the Switch. So how does this work? This is an RP2040 or a KB2040 using a project called GP2040, and it's I don't know what it stands for actually. Game peripheral maybe? I don't know. But the GP2040 project, which you can see right here, OpenStick Community /GP2040-CE. Here is the main home page for it with the cool logo there. So Community Edition, CE. The GP2040 is a code base that allows you to put code and configuration files on something like a Pico or a KB2040 and then choose the mode. It can be switch mode, it can be direct input mode, it can be X input mode, it can do PlayStation 3, PlayStation 4, it can sort of do PlayStation 5 if you have a pass-through USB peripheral that will do a little handshake with a genuine controller. It has some security to not allow this sort of stuff to happen, so there are sort of ways around it. And so what you can do is code this and then configure it via the web configurator to tell it which pins are doing what. Are we using a display? There's little OLED displays. Are we using NeoPixels? So all this stuff is possible with the GP2040, which is super cool. So what I wanted to do is show some of the workflow of that, as well as some little custom arcade controllers for the Switch over there. But first what I'll do is let's bring up a gamepad tester. So gamepad was this hardwaretester.com/gamepad. What I'll do, let's, I'll just show you controllers as I plug them in, and we'll see what we get out of them. So let's try, here's a PlayStation 4 controller. I haven't tested some of this stuff, so this is a real live demo. So PlayStation 4 controller, going to plug it in over USB. Okay, so that got recognized, as you can see there, as a Sony PS4 DualShock, which is great, genuine PS4 DualShock. And it is great because you can test out your mappings and see, maybe not so much on a real controller, but when you start building your own arcade controls or gamepad controls, you can test that your wiring is working or your configuration file is working. So if we try, how about this? This is the Switch Pro controller. Let me find a USB-C cable. That PlayStation controller is a micro USB, but this one is a USB-C controller. So you can see that came up as Switch Pro controller. It has a couple of analogs for the thumbsticks. It also has buttons. Those are not analog on this, at least not in the view of the game tester here. I'm not sure if those can be analog. I don't think they can on this controller. And then all of the many buttons on here. So you can see it has recognized that. Now, this Fisher-Price controller here has the KB2040 in it, and I wired this the same way as Robert's excellent guide there. This takes USB-C because it's a KB2040. And you can see this shows up as something called Pokken controller. So Pokken controller is a Switch controller for a game called Pokken, which is, I didn't know about this until I looked it up. It's a Pokemon/Tekken hybrid. So it's a fighting game that uses Pokemon characters, which is kind of amazing. I need to check it out further. So probably that one was easier to analyze and make a hardware configuration so that this would show up as that device, but it works on a Switch. So you can see here I've got the axes, it's showing up there, the button 1, 0, 2, 3 showing up over here. This shows up as, I think, the start button, or B9 in this case. And I think that's it. No, these are fake up top here, but yeah, let me do that so you can see it a little better. So that's cool. That's showing up as a Switch control. Now, interesting thing is the GP2040 code allows you to designate switches that will, or buttons that will change the mode during power on or power up. So if I unplug it and hold the A button, this should be direct input. So now you can see it no longer shows up as a Pokken controller, it's showing up as a D input. So again, we get these buttons working, and that would be good for something like a Macintosh, or I'm not sure what else you need or want direct input. I think some of the older consoles that have adapters that allow you to plug a USB controller in, and then something like a PlayStation 2 or maybe an original Xbox, I think they want direct input, so this is a mode for that. If I, again, unplug it, hold B, plug it in. Oh, this one's also showing up as direct input. I thought one of these would show up as USB HID, and I may have it misconfigured. And then the C button, I think, is a... Oh, that one doesn't show up. Okay, yeah, so I don't remember if I just kind of screwed up the configuration on this or not. But the interesting thing about this is once you have the code on your controller, if you want to reconfigure it, there is a web-based solution for that. So what I wanted to do actually was take you through the setup on this. So what I'll do is if I go to the download page, so this is GP2040CE.info, and then I click on the download page here. You can see these are the boards that it's going to support. Pico, Pico W, the SparkFun Pro Micro, a WaveShare RP2040, and then the KB2040. So I'm going to use, I've got a Pico here, so I'll download that. And then I'm going to hold the boot. Actually, can I switch? Yeah, I'll leave this camera configuration. So I'm going to hold the boot or reset button there as I power it on. That will put it into bootloader mode. And there, you won't see this, but I'm going to go to a Finder view. And first I'm going to drag a flash nuke UF2 that's also on that page to just blow away whatever was previously on here. It just saves you from weird usage of the flash that could get the GP2040 software confused. So it runs that, it's already done, and now it just returns to my boot disk, the RP2. So now I'm going to drag on the GP2040 software. Wait, let me double check I've got the right one. Yes, that's that one I just downloaded. And there's a installation page here, which is exactly what I just described. That tells you how to get this all up and running. And now when it powers back on, it's actually going to be in, there we go. It looks like it's an Xbox 360. So I think this is the X input mode. So now this shows up to my computer, and you can see there it's showing up as an Xbox 360 controller, which is great. Xbox 360 controllers rule. They're a great controller, and especially if you need something that you can plug into like Steam Decks and computers, that's a great controller to have. So this is a good all-purpose mode that will work in a lot of cases. And to test this, because I just have a bare Pico here, what I'm going to do is let me just readjust my view a little bit, and I'll hide this. There we go. So what I can do is let me double check some of the pin mappings here. So this is the Pico, and it tells me they use these kind of nice generic names like B1, B2, R2, L2, B3, and so on. So let's say I want to test the up button. So that's going to be pin 2, GPIO pin 2. And so I'm just going to ground that. So I can use a little jumper cable here to ground that. So we'll bring up the gamepad tester. I will put one end of this little jumper wire into a ground pad, which thankfully you can tell which those are because they have the little squared off ends on the copper. And now I will touch this here, and you can see on my gamepad tester, hey, it works. It's showing up as a up button press. Now, so that some of that configuration stuff I mentioned is really interesting, and the way to get into this, if we go to Web Configurator, this will tell us, okay, there's a built-in web-based configuration application, and a lot of this works because of the tiny USB work, which is pretty great. If you are grounding the start button, which is called S2 here, when you power this on, it will launch the web configurator. So I'm going to go back and check which S2 is. I think it is down here, 17. So GPIO 17 down at the bottom right there. So I'm going to ground that when I power it on, and then I'll be able to open up a web server to change configuration settings. Oops, is my microphone falling? Make sure that's stuck well. There's some gaff tape under there on my shirt. Let me know if audio gets weird. Okay, so I'm gonna ground this to pin 17, which I think is that second up from the bottom right there. Double check that again. Yep, so I'll ground that. You can imagine having pin headers on this and using it on a breadboard would be a lot easier. And some of my other examples I'll show you over there are like that. So now I'm gonna power it on. Okay, and then I can release that grounding. And so now what that should have done is told this little web server to boot up on start. So what I can do is open up, and there we go. This is a little web server, web page served up by the Pico. It tells me the version, some other stats, and then we can go into settings. So this will tell it what mode do we want to boot up into. Remember this, when we started up, it was in X input mode, so it was looking like an Xbox 360 controller. So let's say I want it to show up as a switch. Now you can do that on startup, like I showed with the Fisher-Price controller, and it actually remembers that from power on, off, and back on, which is pretty cool. But we'll test it here just by saying, okay, you'll start up that way. And then there's a lot of fancy stuff you can do with hotkeys, holding down multiple buttons to do stuff in your configuration, or to access buttons. If you're emulating a controller that has more buttons than you're actually making with your setup, then you can use key combos, which you can set up down here. And then if I head to these configurations, you can see here's the pin mapping. So this will tell you which of these sort of generic GP20 button names are mapped to which pins. You can adjust that here. You can also go to keyboard mapping. If you're going to use it in keyboard mode, you can say which sort of HID keyboard keys are going to be called on which pins, or on which buttons that you press that you've built. You can do things like set up LED. So this is a NeoPixel it's expecting. So this is great because a lot of arcade controllers are built around a notion of one GPIO pin per LED. This instead would allow you to get away with just a NeoPixel single data pin. And then you can set up underglow buttons and that kind of stuff, and color schemes and things like that, which is cool. Here's these LED themes. Oh, you have to enable that to see them. I can enable it and then disable it. So there you go. You can start saying what buttons are going to light up what colors, which is cool. Display configuration. I haven't tried this yet, but if you want, you can use a little OLED and over I2C, and then your controller, if it's maybe a fight stick or something like that, can have a little display that gives you info about the scheme that you're in, which buttons are being pressed, and that sort of stuff. And then there's the add-ons configuration. So this is pretty cool. The add-on that I actually care about for my example is an analog stick. So you may have noticed by default there's no analog controls here, but in this little add-on section you can say, okay, yeah, I'm going to use analog, so that means I'm going to supply power and ground and a voltage divider pin, an analog pin, and measure that. So this tells me, okay, since I'm using an RP2040, the pins that are available to me are 26, 27, 28, and 29, and those can be set up as analog X, analog Y for maybe the left, and then analog X, analog Y for the right if you have a dual analog pin setup. I won't set that here, but I did set it up that way on the one that I'll show you in a moment over there. And then you can also back up these and restore these settings. So what I'll do is just change the boot up mode on this just so you can see it working, so you know there's no tricks up my sleeve. So profile, no, settings over here. I told it to be X input. No, let's do Nintendo Switch. Then I'll drag or scroll down rather, hit save. It says saved, please restart your device. So you can say reboot, and now you can say either I want to go into boot select mode because I still have stuff that I want to drag onto this, reflash it. We can go back to this web config mode, or we can go to controller mode, and that's just going to restart it. We can close this, and now if I come over and look at my gamepad tester, now it thinks it's a Switch controller. So it's in this puck-in mode. I can test out some buttons there. So you can see that little axis 9 is showing up as I touch things. Button 6, button 7, and so on. So that is the basics of getting set up, with just a little hint at some of the customization you can do. And then what I wanted to do, oh yeah, thank you. Yeah, DJ Devon 3, I don't mean thank you, I mean thanks for pointing this out, because I agree, this is really an incredibly feature-rich configurator. It's really pretty great what it allows you to do. Someone said, finally a one-button, Tyeth says, a one-button up, down, left, right, A, and start. So if you want to do cheat codes and things like that, you can assign them to your own little macros, which is great. So let's go over to the bench, and I'll show you some of this stuff in action. Let me hide that there, and oh, sorry, yeah, that camera is looking. I have a funny ISO setting on that or something. Sorry about that. I think I'll leave it. Let me just try to boost one thing on that real quick. Go over to that view. Zoom in a bit there. And yeah, I'll leave that stuff behind, and let's check this out. Let me just try to. Sorry for the wiggly camera for a moment. That'll be a little bit better, I think. Okay. So what you can see I've got here, this is one of my key discoveries that we have in the Adafruit store. And don't buy them all up until I buy one more, because I love these for this project, and I only have one right now. This is a Raspberry Pi Pico Breakout to screw terminal board. I think it's around $24, but it is beautifully set up with all this nice labeling. Lets you know what everything maps to on the pins there. And this is just ideal for setting up arcade type controllers. So here you can see I've got an arcade button or a joystick, and I can plug them into the proper GPIOs to use them for the project. So I'm going to zoom out. And I should say, if you want to buy them, go ahead and buy them. I'll find one somewhere. So what I'll do is I'll go ahead and plug in my switch. So what I've got is I'm just using a little USB-C hub here, just because I didn't have an adapter. But the only thing I have plugged in is the Pico. And if I power this on, I'll go ahead and start it up. And what I've got plugged into the Pico, if I move things into view here, one of the things that's kind of interesting here is I actually had to send this controller here, this little switch controller, in for a replacement on the thumbstick because it had drift, and Nintendo will replace those for free as long as you send it in. So I let them do it. It just came back. It seems like the drift is fixed. But we have a really similar type of thumbstick here, this analog mini thumbstick. It is dual potentiometers, so I have those plugged into these pins GPIO 26 and 27, which are analog 0 and 1 on the Pico. And you'll notice those now operate as a left thumbstick controller. So if I move that around, let's launch Pokemon Shield, in fact. And you probably didn't see that because I'm going to have to adjust this camera again. You can see here I've got a really huge key switch that just seemed like a fun controller to plug into this for now. And so what I have mapped is A and B, and then just this analog thumbstick. But that's enough to be able to just demo some stuff. So here I've got Pokemon Shield. And you can see this is not just a D-pad. This is analog. So I can run fast if I pull it. if I want to just sneak, I can move that ever so slightly and then go fast. All right, so that's the same as this thumbstick right here. Now on the Switch, I think it'll ask me to, oh no, it lets me. Okay, some buttons it'll ask you, hey, which controller are you trying to use? But right now it's actually kind of neat. It's letting me use both. So that has identical functionality there. Oh, here we go. Now I'm out to the map. You should be able to see me walking around here. Here we go. So there's my little character running around. If I want to talk to someone, hit A. Oh no, we're going to get into a battle here. I didn't really want to do that. All right, so let me jump out of there. And so you can see this is kind of cool because if we want to do stuff like a real fight stick, a real joystick, maybe a 8-way or a 4-way stick, if you look at how these are set up, it's just 4 micro switches and ground. So I've got the micro switches, grounds kind of daisy chained, and then just one line coming off that'll plug into one of the grounds on here, and then each of those would have a go to one of the button choices on the Pico or the KB2040 or whatever you're using. And so this is pretty exciting. The kind of 2 things that are interesting about this: one, we can build an arcade controller we can use on the Switch. 2, we can start up in a mode that says, oh, you know what, I want to plug that into my Xbox, my PC, my Mac, my PlayStation, and use all of the different standards, not just keyboard or keyboard mouse type of stuff, which is excellent. The lag is apparently non-existent. It's like 1.5 frames of lag or something like that at most. So really, really high speed from what I've read. And I don't play games where that matters too much, but if you're trying to pull off fight combos, that does matter. And so this seems like a great setup for customizing those types of experiences. And the other thing is, in the Pokemon automation program, we're going to be talking to the Switch. A computer is going to be talking to the Pico or KB2040 or whatever it is over serial and telling essentially the controller that I don't have to touch what to do. So in fact, we strip away all of this stuff. It'll just be Pico to Switch and a computer controlling it so that you can automate your gameplay and just sit back and relax and eat snacks and watch your gameplay itself, which might sound ridiculous, but it should be kind of fun. So that's what I wanted to show. Let me know in the chat if you have thoughts or questions about that. Really very cool project, this GP2040. I'm excited to dig into it a little more than I had before. I'd seen it because of the Fisher-Price controller project, but now that I'm using it for more advanced stuff, I'm really impressed with what it can do. Let's see. Yeah, so I'll again, at risk of these selling out, I'll show you that Pico controller real quick. Let's bring this up and let you know that you can get a nice discount on, whoops, your whole order, not just on this thing, with the coupon code today arcade. Excuse me. So we actually have 2 that would work depending on your setup. One is this terminal block breakout that goes onto a rail. So if you've got a what do you call it? A strip, rail strip, DIN rail. That's the word I'm looking for. I think this one is DIN rail compliant. Not as easy to get to the other side. There's the breakout is sort of laid out like the board, but it's still a cool breakout. And then this one that I'm using right here is the terminal block breakout module board for Raspberry Pi Pico. So if you got that and you got the Pico H, which is the one with the header pin already connected, this one right here, headers are soldered on, so then you got no soldering to do. You can plug that right into that and then use screw terminals to connect your buttons, joysticks, and so forth. Some of the joysticks and buttons you can use, there's, I had this one hooked up earlier. This is a really nice joystick, but the thumbstick seemed more appropriate for the Switch. So we have that as an analog, and we've got these little 2-axis PlayStation style hat ones, and then we have these more PSP thumbstick types of ones. I think I gotta find the breakout that I'm using there. There it is. This is the mini 2-axis analog thumbstick, and then this is the breakout for it. So actually there's some soldering involved if you're going to use that one. And then you can also use these 4-button style ones, 4 switches here. And these have a nice connector, makes it a little easier than the one I was showing over there. And then if you just search Adafruit for arcade button, you will get 400,000 results. So you can pick from the many different buttons as well as connectors, depending on the types of buttons you're using or joysticks. You can get some of these different terminal connectors, which are great. All right, so that is what I want to show you there in the store. Use that coupon code. It's good until the end of the day to get 10% off on anything you buy other than software gift subscriptions. And I think that's going to do it. So thanks everyone for stopping by today. I'm excited about these new projects. We'll be checking in next week on some of the progress on them. Hopefully I will start getting Pokemon automation happening, and then you can watch me watch my computer play my game, which will be fun. All right, thanks everyone for stopping by for Adafruit Industries. I'm John Park. This has been John Park's Workshop. See you next time. Bye-bye.
Thank you.